So I'm going to tell you what page to turn into. I moved this one because I didn't want to go over this until the very end. Just because I think it was going to help you not confuse yourself. This is the last one. And I'm turning to a page in my notebook. Wow. Alrighty, here we go. So I'm going to take this off if I can. I can't find it. Okay, we're crooked. Very crooked. All right, so this is on page 228? No. 220, I can't find it. Maybe I have the wrong number. Maybe I'm going to have to redo that. Yeah, it should be 5.5, that's why. Well, I'll have to fix that later. All right, so this is going to be, this is 5.5. This is going to be on page 239. So this is theorem 5.9. And I call it, it's called HL, or hypotenuse leg. I don't call it that. I call it this. I draw a little right triangle, and I'll show you why. Okay, so this is on page 238. And so I'm going to basically draw you what this theorem is, and then I'm going to label the parts so you remember what the parts of a right triangle are, if you don't remember that. And I might have to make these, I'm making pretty small triangles for some reason. Okay, they're close. All right. So all of the theorems have three parts. So this is called the hypotenuse. Leg. Congruency. Or congruence theorem. I'll just write theorem below. Okay. Okay. Here's the parts of the triangle that you need to know. Opposite the right angle is the hypotenuse. Or, as I like to call it, the hypermuse. And so this would be a leg. Okay. I kind of ran into this guy. So that's the hypotenuse. That's the leg. So basically the right angle stands on its legs, and the hypotenuse is opposite the right angle. I always like to look at it that, you know, if this were an arrow, it would be pointing at the hypotenuse and laughing. Okay? So this is what it means. We need to prove three things. We need to prove it's a right angle. We need to prove its hypotenuse are equal and the legs are equal. Okay? And so I'm going to show you a proof real quickly right here, and we're going to get it done. Okay? And most of the time, we're going to have our triangles where they're all convoluted and touching each other. So I'm going to go ahead, you can't see this, I'm going to go ahead and split these up too and then label them. It's nice to be able to split them up so you kind of see what's going on. But it's also, it's also kind of confusing to split them up. So it just depends on who you are and what you can do. So I'm going to label both of these so we can see them. So this is W, X, Z, Y. This is W, Z, Y. And this is going to be X, Z, Y. Okay. Here's our given. If we can still see it. Our given is going to be WY is congruent to XZ. So we're going to need to mark that. Also, WZ is perpendicular to XY, and XY is perpendicular to ZY. Okay? Here's what I'm thinking about strategy already. I'm thinking, well, that's a side. This is going to give me a right angle, and that's going to give me a right angle. So that might be useful, okay? All right, so what are we going to prove? Well, probably we're going to prove that triangle WYZ is congruent to triangle XZY. Okay, so let's mark up what we're going to do here. It looks to me like WY and XZ is congruent. Very hard to mark on this shape, very easy to mark on this shape. Is that what that is? So that gives me a side. And WZ is perpendicular to XY. WZ is perpendicular to... Did I write that right? I don't think I wrote that right. So let's fix this. This is not supposed to be X. This is supposed to be... That's what I get for going fast. This is ZY. So let's fix that. Okay. So WZ is perpendicular to ZY. So that means that this is going to be a right angle, yeah? XY is perpendicular to ZY. So that means this is going to be a right angle. Okay. Okay, and here's the last thing. They're touching each other, aren't they? So it looks to me like if they're touching each other, I can prove that this is equal to itself, yes? Okay. So I have all my problems, but I'm looking at this thing, and this looks like something that Mr. Crowder told me not to do. Okay, this looks like angle, side, side, or side, side, angle. Am I allowed to do that? Okay, so this doesn't work, but I've taught you a new theorem that is this. So if I get an SSA situation and I have a right angle, I can do this situation. I can do triangle HL. Okay, now I'm going to focus on this. So this would be a side, this would be the leg. Opposite would be the hypotenuse, and this would be the right angle. Okay, now that I've gotten all that planned, and that's the hard part, let's see if we can fill in the blanks here. Okay, and I'm going to pull out a little bit so we can pick up more of this. And I'll try not to put shadows on it. Okay, I need you to rewrite the given right here. I'm not going to do it. I'm not going to do it right now. I'm just going to take time. So we're going to kind of go through what I just talked about. So the first thing, I got this. I'm good. Okay, so again, when we think about things, these are the three things I need. And so I'm going to do my check off. So this is the first thing I got. That checks off hypotenuse. Okay, I like to do easy things first. And so I'm going to do the leg next. That's right here. So what property is the leg going to be? Because I kind of like to do the easy stuff first, and then if I'm going to mess up, I'm going to mess up on the hard stuff. Okay, and when I grade this, I'm going to grade each step and kind of look at what you did, and so it's not going to be all wrong or all right. Every step is going to be its own thing. So this is reflexive. And that's going to give me a leg, right? All right, leg done. Now I just have to prove it's a right triangle. That should be easy, right? All right, let's look here. I'm going to say angle WZY and XYZ are right angles. Okay, and I don't remember why, I just know they are. And so, and I just printed these things off and I lost them already. That's not a good sign. All right, there it is. So, if I forgot, I'm going to go to my little toolkit and look. Perpendicular creates up 1 to 4 right angles, right? Okay. So, I use perpendicular to create right angles. What do I put as the reason? Definition of perpendicular. Okay. You see how I use my toolkit to remember what I'm supposed to do? Because those are all definitions, right? And this is wrong. No, that's right. That's still right. Okay, I was like, that's wrong. I need to move that. Nope, that's still right. Okay. All right. So, but that doesn't, just because they're right angles doesn't mean it's a right triangle, is it? What's the definition of a right triangle? Okay, I'm going to say that these are right triangles, and I'm going to look at, I think I have the definition. Do I have the definition of right triangle on here? Do you have it on your toolbox? You should. Right here, right triangle. A triangle with one right angle. That's the definition of a right triangle, right? Do the triangles have a right angle? So I'm going to write definition of right triangle. And that's what I need. Right triangle, right? Am I done? Last step is and that is the reason. Okay, questions on this? You see what I did? I'm going to leave this up. I'm going to stop recording, but I'm going to leave this up so you can see it. And we're going to do some proofs and stuff. And it's going to unfortunately be